where you have asymptotes, crossover points, holes on graphs, and I will not hold you responsible for one that has an oblique asymptote. I have not done that myself with you guys yet. So yours will have only like horizontal, vertical, crossover points, holes on graphs. And we did do those in class, did we not? Of course we did. Okay, so you want to look back in your notes and get ready for that. Only 2 problems. Only 2. Now, that first one, let's go back and look at it. If it looks like this, can anyone tell me, I better do it now, what types of transformations, or do you have an idea, should I modify the function itself a little bit before I jump into the transformations? Does anyone have an idea? See your hand going up. Yes, Nima.
Yes, first of all, you should factor at -1.
Underneath that square root.
Square root, yes, under this.
Hang on. That's exactly right. X should come first. Professor, make sure it's in the correct form. Just factor out a negative. Now I'm wondering why he asked me to modify that the way it was presented to me. Now we've got to name the transformations, guys. Here we go. The negative sign out front tells me in terms of a transformation to do what? Reflect through the x-axis. Now, he must help this out here. He says, Professor, simplify this or rewrite with the negative there. Guys, what's that negative underneath there indicate? It's going to happen.
Reflect on y-axis.
There you go. Reflect through over the y-axis. The x subtract 4, let's see what underneath there may indicate what type of transformation.
Horizontal shift.
There you go, a horizontal shift to the right. So recap, this slide will be on the quiz. Finally, +3 might indicate to me to do what to finish up? Vertical shift up 3. It's been quite a while since we've seen one like this, but we should know how to do it. Now, should I graph it for you? With all the transformations, or could you guys go through all those transformations and do it? Or maybe I should do it. Oh boy. Okay, let's try to do this. First, you need a parent graph. Now, notice mine has a square root. Wednesday on the quiz, it could be a parabola of some sort. It could be a quadratic. Right now, my parent graph is merely a square root. I'm going to ask you to place that first. Rough sketch. There's my parent. Now by colors here, it says in the green, the way I marked it in green here, reflected through the x-axis. Like that. I'm going to label this at this point as y is equal to negative out front square root x. That's what it represents. Now you guys may not have all these colored pencils or markers on Wednesday, so you can still do this, but you got to mark or tell me on the side here what that represents. I'm good. Next, in the blue, now reflect that through the y-axis. No problem. So take the green through the y-axis and see if you guys would agree. That's y is equal to negative square root negative x. That's what each transformation. After that, it says don't stop there, the red, now shift that to the right. Thank you, thank you, thank you. To the right 4 units. I do that, and that would be, I guess, the blue being reflected. It looks like I have marked that in red. See if you guys, am I doing this correctly if I do this? The blue graph horizontally shifted to the right 4. We okay? Is that true? This graph shift the 4 to the right. Yes or no? Okay. Now what? It says now go up 3. Take the red graph up 3. Let's see what happens here. Now, if all this is correct, I know for sure right here, I guess, that point there will definitely be located where if I shifted up 3. Its coordinates would be what? Out 4, up 3? Yes or no? And I could, if everything's right, just say, Professor, it's gotta look something like this. Sort of like the red, except it's been shifted up 3. Do we agree? Is all that correct so far? Now what do I usually ask you to do at the end to make that final swoop look nice? Find the x and y intercept on your final graph. So guys, before I connect here, in fact, I'm supposed to connect the ring here. Let's find the x-intercept. Easily done. You go back to your original function, set this equal to 0. We've done these before. Got negative square root, negative x subtract 4 plus 3. And you gotta solve for x. We'll move that 3 over, no problem. Just be very careful with all my work here. Divide or multiply by a negative, that makes it even look better. Looks like that at this point. Is that true? Yes, no? Now what would you suggest I do now, because I'm trying to solve for x? What's the next step? Square both sides, which I can here. Absolutely, so you're going to end up with 9. And the other side, of course, when the square root drops off, you're left with this. And I can easily finish that up if I do not have a mistake here. The negative x what? Plus 4. That's simply out. I see a 5 here equals negative x. Is x equal to a negative 5? I did it quickly. Yes or no? So that should be my x-intercept on my final graph. Let me write this as an ordered pair so I keep up with it. So make what to a negative 5 now. Show, I'll show it right here, this should be my x-intercept on this final graph. Y-intercept. Find the y-intercept a little easier. You replace all the x's by 0 back at the original. You got negative square root, replacing x by 0, negative 0 subtract 4, plus 3. F at 0. Bring this up. I think underneath there's a positive 4, so that's the square root of 2. Plus 3, and do not let me make a mistake, is it 1? I think. All right, this is ordered pair, 0, 1, so it tells me also this is the y-intercept on this final graph. Now I have marked in color here, I did a green for the final. So let's connect those 3 points. And see if you guys would agree, does it look something like that? Something like the red that's been shifted up 3, then maybe I picked up the x and y intercept. Is that reasonable? And there's your final graph. Yeah, one of those on the quiz Wednesday. How's that look? Is it reasonable? And of course, you know I'll be asking things like, on the final graph, domain. Guys, the domain of that final green graph up there, it looks like it's a negative infinity, so you guys will agree, over to what, 4? Leave 4. Range, the up and down. Looks like the negative infinity up to the top, as top number goes up to is 3. Yes or no? Is it true? And I could name also other things, or ask you other things about this. So guys, it's going to take a little effort. I love this problem here. I love this problem. With all the different transformations taking place. So you have one of these, where you have a parent graph and you gotta do all the transformations. Okay? The second problem, I think I mentioned what? Oh yeah, it's gonna be a rational function. And I'll leave that up to you to look at. We have to graph it with asymptotes and crossovers and holes on graphs and so forth, and we've done those in class. Dima?
Excuse me, professor, is there any priority to start graphing a particular function? For example, in this example, we start with x minus 4 under the radical.
Dima? So I go from left to right. I've had a discussion with some of the colleagues here on campus. They mix it up. They might start with this first. Is that what you're saying, the order? You might do it in a different order?
Yes.
You could. But keep in mind, no matter what order, you should end up with finally the same graph I have. Where was it? This graph. Okay, so you may have in your mind a different order to follow. I just sort of went from left to right. Okay? Guys, anything else? And then your rational function, your asymptotes and all that business. So please get a 10 out of 10 on this. And my TAs have an extra credit for you. I'll let you know before we leave, right guys, before we leave today? Okay. So they'll let you know when they want that returned to them. And this will count maybe as what, a half a point?
4.
A fourth of a point.
Yeah,
A fourth of a point.
4 points.
Oh, 4 points. Wow.
Well, wasn't it because you
I
said?
thought you said a fourth of a point. This would be 4 points?
4 points? I'll ask you again. I'm not sure.
Hell yeah. Would you guys prefer a fourth of a point or 4? 4. Of course, you know 4 points, right? We'll talk.
Okay.
You'll get something today to work on. All right, guys, any concerns here? That's your quiz. Now, the topics coming up for chapter 4 to close down. I am going to start trig at the end of class today. It's going to be starting. But I'm concerned, and I think from some of the questions my 2 o'clock session asked, they are concerned. I think we're all concerned. Chapter 4 is loaded. It is one of the heaviest chapters in the textbook. And why? Well, here we go. Part 1, now some of this will be recap, some might be a little new, but I think it's well worth looking at all of this. Okay, part 1 is called. Let's call it a recap. Guys, first, yes, an exponential function. Closing chapter 4 down. F of x is equal to a raised to the x. That's what an exponential function looks like. A little restriction here, that base a must be, and I think we all know that now, must be greater than 0. But do not let a be 1. And you're raising that to a power. That's what it looks like. Now I think, let me check, see if I did. Yeah, I did. F of x is equal to 2 raised to the x. So on the side here, guys, it's a basic exponential. And its shape, use that color here. You can use a table to plot points. I think we did that in class. Its shape is going to look something like that. It's roughly 2 raised to the x. That's the graph of an exponential. There's some horizontal asymptote involved, and it looks like that. Next, we have, hang on. Oh, beautiful. Before I leave this, the domain here is negative infinity infinity to positive infinity looks like. Now what's the range though on this red graph? This exponential, the up and down. How would you describe it? 0 to infinity, headed towards 0, we'll never get there. 0 to infinity. Now, number 1. Now, number 2. I'd like to point out another function, we call it g of x. I'll just a little recap here, which I think will be well worth it. Looks like this. I brought this one in. G of x is equal to log base A of x. Some restrictions, definitely there's some restrictions here. A must be greater than 0, but do not let A be 1. X, now guys, tell me what the x there is. What is the domain? X is domain, so that tells me something about the domain if I see a log function. Anyone remind me, was there a restriction on the domain of a log? X must be greater than 0. We'll place this into a notation, it's that. Now we'll try something. We try g of x is equal to, let's try one with a number here. Let's try log base 2 x. I've got 2 raised to the x, that's an exponential. Now I like the graph on that grid above there. What do I think log of x base 2 looks like? Does anyone have an idea, or we could block points? Can anyone describe it for me? And I'll sketch it. And I'll place it in a different color on the same grid. Does anyone know what the shape may be? Log of x base 2. Far about it.
Reflect this by the y equals x line.
Ah, beautiful, here you go. And professor, I remember us discussing there's a y is equal to x. Line was involved. He says, and take that red graph and reflect it across that y is equal to x, and you'll get the graph. Now, Farbach, can you tell me more about, and put in blue here, more about that blue graph, that log graph?
So it's the domain is all positive. So
Okay.
it starts from like it's got a asymptote. Yeah.
Like this?
Yeah.
Doing something like that. Would you guys agree? And by the way, does it sort of look like even on my rough sketch here? Maybe the red and the blue are reflections of one another across that diagonal line. Y is equal to x, as he told me to sketch there. Farbach, before I leave it here, can you tell the class where the x-intercept is on this log graph? Where's the y-intercept on the red graph?
0, 1.
0, 1. You guys agree? So I just wanted a basic exponential graph. I did mine in red. That's what they sort of look like. All of them do. A log, basic log graph. I did it. And that's what they look like. By the way, are these two, could I refer to them as inverses? Are the inverses of one another? The way it looks here? Can I consider these two to be inverses? Nima? If these two are inverses, you'll say, which two, Professor? I'm talking about the red, which I identified as 2 raised to the x. You put that in there. And the blue, what I just did with his help, was the log. Base 2 of x. Anybody, can I actually identify these, the red and the blue, as maybe being inverses of one another? If so, something special should happen. The first, are they inverses, do you think?
Yes.
Okay, let's do this on the side here. I can't get a quick response here. Let's take one of them. Suppose you take this red one. Y is equal to 2 raised to the x. Take the red one. It's given. Let's call it, y, I really like that y, e raised to the x. I like to find, put a comma here, guys, we'll name this a function, like I did, f of x. Rather than use the y, I'm gonna use f of x. I like to find this red function's inverse. First, is it possible for that red graph to have an inverse, for that red function? Does it pass the horizontal line test? The red one? It does. So we can have an inverse. Only two steps to find an inverse. Step one is interchange the x and the y. Yeah. Now interchange the x and the y. Step two of the two steps to find it, solve for y. First you interchange, now you solve for y. Now that's a little tricky. But can someone be clever for me and tell me, now I'm gonna put in a color here for a reason. What do you think y will be equal to? And I'll tell you, the middle school kids could not find y here on this.
Log 2x.
I'm hearing it.
Log 2x.
Y is equal to log, what, base 2 x. That's 2 raised to the x's, or 2 raised to y, x equals 2 raised to y. That's 2 raised to the x's inverse, using those two steps. And for our body, I think that's the one, isn't that the one we just graphed? In the blue? So the red and the blue are inverses of one another. Now, if they are inverses of one another, we accept them as inverses of one of the guys. Here goes. This is a check on your inverses. We do this also. We form the composite. Maybe in this order. If these two are truly inverses of one another, what should I get for a response if I form the composite of the two? X. Let's see if I do. This is f of the inverse, and I think the inverse here is this, log base 2 x. And it says go back to the original function. Here's my original function up here. Replace, put that in there. You end up with this is 2 raised to, look at this, log base 2 x for composite. And what should that be equal to altogether? X. That's your check. Then we'll make general statement here shortly. It should also check in the other order, put the inverse first, then the composite on F. You should also get X here for a check. I guys want to squeeze this in. This time I'm placing the function, the red, into the blue. I hope I get that right here. Okay, log base 2, placing the red into the blue, make that 2 raised to the x. That's supposed to be also x. Can someone tell me why? It's supposed to be x. I'll accept it as a proxy. Can someone tell me, I know it's been a weekend. Can someone tell me why, little thought here, why, yes, Professor, I know it's x, we'll accept it as x, but I can tell you why also it's x. Go for it.
Because log base 2 of 2 is going to be 1, and then to the power of x, it's the same as saying x.
I don't simply you're saying, oh, log base 2 of 2, you want to do that much first. You got 1, and 1 raised to the x is x. So 1 raised to the x going to be a 1. Something else. Miriam.
Log base 2 of anything equals x is 2 to the x equals that thing. 2 to the x equals 2 to the x.
I love that, and we'll write this property here shortly. Something else. See another hand going up. I see a couple hands going up. Yes?
We use the log to find power, so we just get power is x.
He says, now you can use power property if you wish on this. He says, you've got a power here. Apply the power property we discussed, I think, last week. Lift that power out front, and go here, guys, and have x lifted out front, log base 2 of 2. Just lifted that out front. Now, how much is this?
That's 1.
That's 1.
what I was trying to say.
No, but log of 2 base 2, is that 1? And then x times 1 would finally give me the x as they said it should be. And that's why the property is written like this. Wow. Now, Jonathan, in the 2 o'clock session, let me see if I want to try something here. I do. Let's write this as a general statement, guys. You see what's happening here. The general statement is, let me think of a good way to write this. A raised to log base A of m automatically has to be m. That's what we're doing here. If I solve this, log base A, I think a good way to write this. Why not? What can I do here? I think a good way to write the other property to make a little sense here. Hang on, just think about how to write it for you. Okay. What should that be equal to? The way it's written. Is that x? Just a few properties. So, by the way, did we go through all 3 properties of the properties of logs? I think we did that, didn't we? Properties?
Is there restrictions on M?
Beautiful. Right here, there might be a restriction on here. Well, the base here is going to be greater than 0. M here, you got it. Hang on just 1 second. We can do that right now. So far, so good, though. Now, Jonathan, this is a beautiful recap. We're moving into part 2 and I'm going to answer your question. I'm moving into part 2 here. And that is this. And then I think all this will start coming together. Yeah, sure enough, I did this. Find the domain of these functions. First one, guys, we'll talk this. F of x, no solving. I'm going to use a natural log, the ln notation. It looks like that. If I use ln rather than log, it means the base is e. All I'm concerned about is, may I replace x by any number I wish? That's called domain. Or are there some restrictions? And what's going to help me to decide that is, Jonathan, let me go back here and look and see if I have a place here that may help me here. Guys, my log, oh, here's it. Here's my log graph. That's what this is, ln, it's a log graph. What was the domain on this basic log graph when I did it earlier? X must be what? Greater than 0. That right there must be greater than 0. That's my domain. So that says, in my case, if I expect this to work out, this must be greater than 0. Or I can't deal with it. And if I go further and solve for x, I got x is greater than 3. And you guys who like interval notation, this is your domain. And I know your textbook usually just ask you for the domain, not the domain range on this. Just find the domain, find the domain. Miriam, if I got outside that domain, from 3 through infinity, suppose what's wrong with 2? I can't use a 2. It's not in there. If I put a 2 back here, guys, get 2 subtract 3 is negative 1. You can't find a log of a negative. It just doesn't exist. In fact, that basic graph tells you right here, this is a log graph. It's everything to the right of 0 for the domain. Jonathan, something else here. H of x, another example, is equal to this. I have, hang on, log base 3 of this. I want its Can't go wrong in domain, guys. Cannot go wrong on domain. Jonathan? Keep on calling you, you're concerned about this? I would assume then that, Professor, for this to exist, that inside there must be greater than 0. So x over x plus 1 must be this. You know what this sort of reminds me of when I'm doing this? You remember the square roots? When I asked you to find the domain of a square root, the process there was to do what? What was it if you had a square root? I'm going logs now. Suppose you had a square root, what was the process there to find the domain? You took everything underneath the square root and said what? Greater than or equal to. This one you can't let it be equal. Just greater than. Okay guys, I need to solve this. Oh, by the way, before I leave this one, if I had, which I'm not supposed to, and put an equals mark here, then I would be including 3 in my domain. I would put a bracket on this. Now, if I should take 3 back real quickly, this becomes 0. You cannot find the log of 0. It doesn't exist. Nor the log of a negative. Go for it.
It really just shifts the S to.
It does. I'm sketching.
Yeah, before it was like, it shifted the, x-intercept, now it just shifts.
It's supposed to shift the asymptote.
The asymptote.
Okay. Now let's get this domain out of the way. Guys, to deal with this, please tell me, give me a clever way to find the domain, or how you solve this to find the domain. Help me out. From those test results, I've got some clever students. How you gonna solve that? X over x plus 1. You wanna multiply both sides by x plus 1? Can't. I don't know what x is. You might be multiplying both sides by a negative, and that symbol's gonna reverse on me. So I cannot multiply both sides by x plus 1. What am I gonna do? Yeah, I'm sitting down and thinking about, it's gotta be this, it's gotta be that. That's something else that we've done in class many times. Sign analysis. Sign analysis. I saw some students using sign analysis on the exam. Now, anyone take a look at this and be careful. What are you going to consider as your, I think I call them critical numbers. What are you going to consider as your critical numbers, and I'll get test numbers. What do you think this looking at this might be the critical numbers? 0, I'll pick 0, and 1, a negative 1. And both these will be open in this case. So I consider the numerator, got 0. I consider my denominator, x cannot be equal to a negative 1 there. Those are called my critical numbers. Now we'll test. 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 Out to the left, we'll try a negative 2. We've done this many times. We'll try here a negative 1/2 many times. Out here we'll try 4 many times. We'll start with negative 2. If I replace x by negative 2, I get negative 2 over, help me out, negative 1, which turns into a positive 2. Is positive 2 greater than 0? That means I have quickly discovered part of the domain. In between, it may work. Let's try negative 1/2. So negative 1/2 here is going to be negative, put the sign here. And down here, negative 1/2 plus 1 gives me a positive 1/2, it's a positive, and it will not work. Out to the right, prime 4. I think 4 is going to give me a positive for sure. Is that true? And there's my domain. So my domain of this would be a negative infinity up to a negative 1 union 0 to infinity. And you're done. One more. Let's call this g of x. I brought another one in here. Last one for a domain type problem is ln, back to a natural log of this. I found the domain, acceptable x's. What would you suggest I do immediately, like I did on the others, and go from there? What should I do first? What must be true about this inside here? gotta be greater than 0. For log is always greater than 0. So 16 subtract x squared must be greater than 0. I hope you recognize that this is a difference of squares. Going in factor, in the order I see it. And then I would suggest difference, sign analysis, again, from that difference of squares, sign analysis, where my critical numbers are -4 and +4. Open. Now, to save me a little time, you know how to do sign analysis. Can anyone tell me where do you think I'll shade? On this one. I'm not gonna show all the testing. Where do you think I have to go through all the testing? Where might? Is it in the middle? In between these two? You test? Okay, if it is, my domain quickly on this one is merely the acceptable x's must be caught between -4 and a +4. There's your domain. And to do it. If I ask you for domain, domain's easily done on these. Now, Johnson, here we go. Keep on mentioning you here. Part 3. I like to sketch. You guys are about to get all this recap up here. I like to sketch the graph of this. Y is equal to 4f of x, negative out front, log base 3, 9 subtract x, subtract 2. You would definitely have items like this on your test Friday. Okay. Here we go. You guys have a transformation problem Wednesday. This is going to be done through transformations also. So I have in my directions use transformations. Guys, I'll need a parent graph and then also have to identify the transformations.
I just want to ask, so for the element, maybe I just kind of forgot. So did you use sign analysis or did you just automatically determine those between maybe?
I used I didn't show you all the numbers. I said to save myself a little time there. We've done sign analysis so much. You know what to test those numbers. I didn't show the testing.
I know.
Okay. Here, guys. Here we go. You gotta reflect through the x-axis. Beautiful. I'm trying to think who helped me out here. I think it's Nima. I did one on square root earlier. That's the type you're going to be responsible for on Wednesday. This one's going to be on Friday. Still transformations, but it's got a different paragraph. It has a log graph. Can you tell us what you might suggest I do before I identify another transformation?
We can factor at -1.
That's what you told me last time. He says, Professor, you had better factor out and make sure this is in the correct order. X coming first, like that. Now, since I've done that, I'll put this in green. I have now picked up another transformation. This is a reflection through the y-axis. Much like Wednesday's quiz, much like that problem over there. That's why I brought that in today. Next, I see x subtract 9. I'm going to do this in blue. And it looks like this means there's a horizontal shift to the right. And then the subtract 2 tells me, which is going to be interesting, I guess I'll do it in black. A vertical shift down 2. Is it true? Okay, now again, Wednesday, you'll have, did I erase it? I guess I erased it. The very first one I did there was the square root function, okay? and the transformations on it. Friday, you'll have probably a log. And again, they'll do transformations, doing the same thing here. First though, I'm doing the same thing as I did earlier, I need a parent graph. And it's not the square root graph this time. I love this problem. Here we go. Guys, what am I going to use for a parent graph? What does the parent graph for, I'm doing log here, not square root. What's the parent graph for a log look like? And in fact, I think we had one, I think still on the board. That. Is that a parent graph? So just use that right now for the parent graph. It has an x-intercept of 1, and it does this. Guys, when you label this as y is equal to, then move along here, log, I think I should use a base 3 x. Barbot, if it's an ln, a log base 4, a log base 2, still has that shape. I'm not gonna ask you to draw a perfect sketch, it's the same shape for all of them. Now let's pick up the transformations. The red says reflect that through the x-axis. I'm gonna be careful here, right on top of the board here. Tell me, is this it being reflected across the x-axis? If so, I'll label this as y is equal to a negative out front, log base 3 x. Is that true? Next, I see in the green, now reflect that through the y-axis. Well, here we go. Not let me mess up here. Now you're going to take the red and reflect it across the y-axis. Please tell me, I'm trying to do this, I guess, in green. Might it look something like this? The red flipped over the y-axis, might it look like that green? The shape. And we'll label that as y is equal to for the green. I got a negative out front, log base 3, a negative inside. Next, I have in blue, shift that to the right 4 units. Let me get ready for it. Okay, guys. We're supposed to shift to the 9 or 4?
It goes in 9.
9, 4. 5, 6, 7, 8, 9. To the right. Now, I'm taking that green graph and shifting over horizontally. Guys, this point right here shifted over itself at -1. Shifted over what? 9 to the right? It's going to land at 8. And that's being done in blue. I know for sure it's going to land there. This point. What else should I be cautious about as I'm shifting everything over 9 to the right? Is there a vertical asymptote involved here? Is that y-axis acting as like a vertical asymptote on my graph? So it's also being shifted over, so is it, this y-axis, is it now over here? Do it like this. Is that true, guys? Now, is that enough to get the shape? I've got the vertical asymptote shifted over, 9 to the right. I've got that blue point staring at me. It should take the same shape as the green graph. Does it right now, without additional points, gotta look something like this. I may have mine exaggerated somewhat. Here to here. Is that true? Am I finished? No, there's one more transformation. And I'm gonna, what did I mark that in black here? Just put it down, shift it down 2. Vertically shift that blue graph down 2. This is the point where I should stop. before you do it, even though you know this point right here is shifted down 2, you know where it's gonna land. There's no doubt about that. Is that gonna be what, -2? Yes or no? If I shift it down, I'll place it right there. Yes or no? Is that point there for sure? What do you think I'll be asking, as asked on the very first transformation in class tonight? At the very end, what else am I interested in? The x and y intercepts. And then I'll get the final graph. Guys, the x-intercept? Now watch carefully. You set y equals 0, as always. Looking at my original function. And you're gonna solve for x. We'll move the 2 over. Do not let me make a mistake here. Trying to get the x by itself, trying to solve. Multiply or divide by negative. Now this looks like this. Now, same process I did earlier on the square root graph, except this one's not as easily done. I gotta solve for x. Has everything been done correctly at this point? There's no mistake? Oh, my class, I can tell this is a Monday. Are we okay so far?
Yeah.
Okay. Now, not as easily finished up as that square root was earlier. Can someone tell me? Be clever. What would you suggest? Because you gotta get x by itself, you gotta solve for x. Nadia says, Professor, it means this. She knows what it means. It means base 3 raised to a -2 is equal to that. That's what the log means. Now the word log's gone. You translate it, or she translated it for me. Now I can solve this thing. 3 raised to a -2 is 1/9. No problem there. Is equal to 9, subtract x. Guys, to solve for x and get the x, I'm gonna move the x over. So x is gonna be equal to whatever 9 subtract 1/9 is. 8 and what? 8 and 8/9, I guess? A strange x-intercept, but here goes. 8 and 8/9. Y-intercept, that's done. Now y-intercept, a little bit easier somewhat. We're going to try to find f at 0. I go back to my function and replace x by 0. I'll show it right here. Looks like that. Trying to find the y-intercept. So this becomes a negative log base 3 merely 9 subtract 2. Now, Miriam, please tell the class what is another name just for that? 2. Log of 9 base 3 is 2. 3 squared equals 9. So she says, Professor, you got your negative sign out front. This is merely 2. Subtract 2 on the end. All those negatives going on and 2 is going on. It's -4. So your y-intercept is 0, -4. When I place those on there, yeah, I'll mark this in black here, and connect, the graph will be finished. First, guys, the x-intercept is 8 and 8/9. Oh, look at this. 8 and 8/9 is so close to 9, the vertical asymptote. Very close to 9. So it's over here. This is your x-intercept on your final graph. Plus, we picked this point up earlier. The y-intercept, if all this is correct, it's down here at -4. Mark that. And guys, with all that said, look at this. Here's your graph. Doing something like this. not touch that vertical asymptote. Guys, it swoops down like that. There's your final graph. Is this helping today? Is this sort of helping?
I just had a question, so.
Go ahead.
In the beginning it was, so in the beginning we had, negative log for b, 9 minus x, right, and then, oh, okay, never mind, cause I remember we factored out the negative, so.
Yeah,
it
we
was-
did.
Okay, so that was like negative x minus 9, right, or like negative x parentheses.
Right here it is.
Oh, and then here we just didn't, okay. Okay, never mind, I think it makes sense. Yeah, cause I was just looking at x and just like how we were finding it, I thought we were gonna have.
Yeah, I just said this equal to 0.
Okay, just the very original equation?
I went back to the original, if you don't use this, you use this.
Right.
I use the original.
And I'll get the same answer. if
Same
we
answer,
use-
same answer. Absolutely.
Oh, yeah, cause we just factored it.
Okay, now to close this down, you look back in your notes on the transformations for that square root, for Wednesday. I think I asked you for the domain and the range at the end here. So guys, on that black graph, this one that swoops down like that, its domain is, let's see if you guys will agree, negative infinity over 2, 9. Range, looks like implied is what? Negative infinity through infinity. Let's see. Why not? Someone answer this for me. The limit as x is approaching 9 of my function, I'll write it f of x, is equal to what? A lot of you guys moved into math 7. I think as you get close to 9, it looks like, right here's 9, that's a vertical asymptote. As my black graph is getting close to it, it's getting close to it, closer, and does not touch it. What's it doing? How's it behaving? Is it rising forever through infinity? Why can I not accept that answer? I didn't tell you which side to approach. I didn't tell you which side to approach. Nadia tells me, she said, wait, Professor, you didn't tell me which side. In fact, on one side, nothing's happening. So I cannot approach from the what? Right, because there's no graph to the right. So I must put a superscript of what here? A negative to show approach from the left. And then Miriam, I'm going to accept your answer. It's infinity. If you approach 9 from the left. You guys want to find in calculus, one side may not work, right, Mr. Park? As you find the limit from one side, then check the limit on the other side, sometimes you don't get the same answer, and something happens when that happens. So I'll just let you know this will happen in math 7. Guys, I like this. Is this now making things now come together here for us? Must be planning for the, I want to get into trig, but I can't do it yet. Go ahead.
So for the limit, I can't really see what it says. It says,
X approaching 9, superscript, negative sign.
Okay.
Okay, guys. Now, let me check and see. Checking my time here also. Jonathan, and my 2 o'clock session. You guys get questions. They're doing the homework. They had questions, that's what sort of guided me. I had this ready just in case. I thought, ooh, from those questions coming up at 2 o'clock, I had better do this. I wanted to jump into it 3 o'clock when we first started. I wanted to jump into trig so badly. One of my favorites. But I can't quite do it yet. Okay, guys, not quite done with this yet. Now, slow down a little bit. Erase this. And we'll feel pretty good about chapter 4. All together here. Okay, let's just call this part 4 coming up. Then we'll slow down and have you guys try something. Part 4 is this. Oh boy, it sure is. Given. F of x is equal to this. There's my given function. I'd like to find this. And this. And this. What should I be concerned about first? If you're asked to find the inverse, what should I be concerned about on the original function? How's it done? What's the one condition, I think the author of your textbook says they will satisfy this condition. It's gotta be 1-to-1. Well, it has no inverse. So the author of your textbook, he puts on the side here, and I'll put it on the side here on the test also. This is a 1-to-1 function. So it does exist, the inverse does exist. To find it, only 2 steps to find the inverse. Step 1, interchange. Interchange. I give you partial credit. Step 2 of the 2 steps, solve for y. Now, when we start, down this map here, I'm gonna start moving some terms around. I'm trying to get the y, did I interchange here? This should be y. Okay, I interchange my coordinates. Now I gotta solve for y. And I see y's inside here. So guys, in an attempt to solve it, I see different ways to do it. I'm gonna move things around and rewrite, if you don't mind. I'm gonna move this term over so it becomes positive. And move the x over to the other side. Let's move things around. Now, can someone tell me, it's gonna look strange as you know why. I'm trying to get this. Can someone tell me at this point, what might you do? Trying to solve for why those kids across the street could not do this. Yeah, 3 again. 3 raised to 2 minus x is equal to, you just translate the log. That's what it means. Log's gone. Now I'm hoping now I can solve for y. Easily done now. Move the 1 over. You have y by itself. And that's what they asked me to do, solve for y. To make this a stronger statement, guys, this is the inverse. Beautiful. There's the inverse. Inverse of what? This. Now on the side here, before I jump in and find the domain and the range, let's do a quick check. You guys want to check the inverse. I'm going to use this particular direction here. Here's the way you check. Find the composite, and hope to get an x. Now, the way mine's written says place the inverse into the original function. I'll go for it. That's what this means to do. F of the inverse. Now, if I place the inverse, here's my inverse, into the original, it'll look like this. 2, subtract, log, base 3, in place of x, put it in a different color so you can see it. I'm placing the inverse, which is 3 raised to this, subtract 1, and then of course on the end up there was plus 1. place one into the other. If I clean this up, this is 2 subtract, guys, inside there is log base 3 of, the ones cancel. You're left with this. Now, what do we do now? Supposed to show x. All this, supposed to, when you simplify, it gives you plain old x, just x. I'm not quite finished then, something else has to be done at this point. What has to be done?
We should take out the 2 minus x.
Something else.
Put it in front, and then.
I could use a property. Okay, you want me to, John, you want me to write this as 2 subtract, hang on, we use a different color so everyone can see it. He's being clever, he's this professor. Why not rewrite this right here? By using the power property. Lift the power out front. Now be careful here. That's 2 subtract x. Lift it out front. And then of course you have log base 3 of merely 3. Power property. This would be power out front. Now how much is this right here? That's 1. Log of 3 base 3 is merely 1. So you're looking at now 2 subtract merely 2 subtract x times 1. Please tell me, if you simplify that further, will the 2's cancel out? I think you end up with a positive x. Which we want, and that's your check. So now I feel good about all this, that this down here is truly the inverse. It's a check for me. Okay guys, hold on. Now let's go back and find the domain. The domain on the inverse, where's it here? Now someone help me out. What should the domain of the inverse be equivalent to? The range of the original, if that would help me. Just recall that inverse. And guys, what's the range of the original? I don't know, but I have the domain, I have the function down here. You might be able to look at this function down here, this is the inverse, and tell me, are there some x's I can use? It says 3 raised to 2 subtract x. Is there some x out there that I could not use for some reason? Or may I use all real numbers? May I replace x by any number I wish? Or not? Okay? Or you can go back and say, Professor, can I find the range of this one? It should be equivalent. I'm gonna do this. I'm gonna do this, and then this is what happens here. Let me do a real quick sketch on this. The original function. Let me do a real quick sketch. With your help. Here's the parent graph. That's the parent graph. I'm not gonna label all this, we've already done some of this. Guys, we'll turn this around, I'm gonna sketch it. This is negative log base 3 x plus 1 plus 2. Just turn it around, a little easier. Okay, reflect that parent graph through the x-axis, you get this. Real quickly. Shift it over 1 to the left. Over here at negative 1, it's going to be my asymptote. And my point's going to be here, and it looks like it might, looks like that. That's my graph shifted over 1 to the left. And it's supposed to go up 2. Move it up 2. Basically, I think that's the graph. It's going to tell me what the range on this final graph is if I accept this as my final. What's the range of the graph? It's a negative infinity through positive infinity. Just the range, which should correspond with the domain of what I'm looking for, the inverse. So the inverse here has a domain of this. Now, let's pick up the range of the inverse when we finish. Range of the inverse should be equivalent to the domain of the original. I've got the original graph up here. There's this graph. What would you say the domain of the original is? Everything to the right of negative 1? Negative 1 through infinity? That's this. Where's this? And yes. Negative 1. Everything to the right. Aiden, got a question for you. Can you tell the class another way I could have found the domain of the original? I graphed it. I could have found the domain of the original, which is the range of the inverse. What's another way I could have found that domain without a quick sketch?
Of the original function or the
Yeah,
inverse?
of this function. This function.
Well, you could just agree that whatever is in the log, x plus 1 cannot equal 0.
This has to be greater than 0. We said that earlier. Solve it. X must be greater than what? Negative 1. Same answer. Without the sketch. Wow. I think Rich did a pretty good job recapping chapter 4. Are we finished yet? No, we're not finished. Does this help it? All of chapter 4 is just falling into place. So you don't have to really worry about all this until Friday. Any concerns up to this point? Is it all falling into place the way we're presenting this? I hope so. Okay. Before that break comes up though. Marina? Art? I want you guys to sort of talk to them right before the break about this extra credit, and then you and I are going to talk. I thought it's just 1/4 of a point. Now you're saying 4 points. That's like adding 4 points to your score on that last test. That would help. But they're going to let you know when and where and what they want in order for you to get those 4 points. Guys, before they do that, before we take a break here. Oh boy. Here goes. This is part 5. And we're closing now. First one is find the exact value of these expressions. And I'm going to stop. Find the exact value. First one. Am I ready? Of course I am. Here we go. Now we're good discussion. You have no calculators. You see e raised to ln, natural log, base e. E raised to ln 8. Answer is 8. Immediately. Try something right with it. Another example here. We'll use e this time. Maybe 3 raised to log, let's say base 4, 10. Can I say automatically the answer in this case is 10? No. How did I mess it up? How did I mess this one up so I cannot say automatically 10? I've got different bases going on. I start out with the base 3 and I threw in a what? Base 4? If I change that, it is 10. It's 10, just through a basic property of logs that we're dealing with here. So watch out for that, guys. Part B, another example here brought in, looks like this. Beautiful. 4 raised to log base 4, 6, subtract log base 4, 5. at least they all have four, base four to work with. Got it? Any answer? 6/5. Merely 6/5. Now why? Because first, this could be rewritten to use the quotient property as log base 4 of merely 6/5. You subtract logs, you take it back into the quotient property we discussed. And then now, think this has the same basis here, look at this. Automatically, answer is this. Finished. And last one, looks like this. Log base 6. Oh boy. 9 plus log base 6 of 4. Answer is 2. Why? I'm adding logs, it says changes back to a product property, and rewrite this as log base 6 of a product 9 times 4. Which is equivalent to, I'll squeeze it in right here, log base 6 of 36. And I heard the answer was merely 2. 6 squared is 36. I hope I've answered some questions. I thought about this before I came to class. And then my 2 o'clock session, oh boy, I said, I really need to do this before I start that chapter 5. It's all just coming out together to this help. It took me a long time to do it, but I hope it helped. We've got a few minutes here. Arena, Mr. Park, come on up.